Hello everyone and welcome to this video about local secondary indexes on DynamoDB. In this video we're going to learn what is a local secondary index and how we can use it going through a real world scenario example. Okay, so first of all let's introduce the concept of LSI or local secondary index. LSI is an index with the same partition key as the base table but different sort key. This is also why it's called local. It's called local because every partition of an LSI is scoped to a base table partition that has the same partition key. An LSI can be created only at creation time, only at table creation time. So it can't be created as, for example, you can do with the GSI when the table is already created. And same thing when it can't be deleted if the table already exists. So the LSI will be deleted when the table will be deleted. Another thing is when you use an LSI, you can use both or the consistency model supported by DynamoDB. So you can use eventually or strong consistency. Queries and scans run through the LSI consume read capacity units of the base table, and when you write an item to a DynamoDB table, you will consume write capacity unit of the base table as well. So now let's see this LSI in action using an example. Okay, let's explore this example that I took from the AWS documentation. So we have a table which represents forums and threads. Forum name is the partition key in this case, and the subject is a sort key. Then we have other attributes, for example, last post date time and number of replies on the thread. With this table structure, it's easy to query different access patterns. For example, I made two here. Like the first one will be get threads for a specific forum name. For example, it's easy to query by forum name. For example, S3. Give me all the threads with forum name equals S3. It's a straightforward query, and we can do that with this current structure. Second one is get an ordered list of threads based on subject. Also, this one is easy because you can, for example, query the table and returning all the threads with partition key S3 and subject beginning with the letter A. This is a query we can currently do with this structure, but some of the access patterns can be more difficult to query. For example, let's say we want to answer the question which forum threads get the most views and replies. In this case, we don't have a direct access pattern to do that. Or how many threads were posted in a particular forum with a particular time period. Let's say we could use different approaches with this current table structure. One could be scan the entire table, but scanning the entire table will, for example, with a table with millions of items, can consume a large amount of provision, read throughput, and take a long time to complete. A more scalable one, a more, let's say, efficient one will be adding LSI, a local secondary index, on last post date time, for example. Let's see now how the table looks like with the local secondary index that we just added. This is how the table looked like with the new index that we add. So we added the local secondary index on the last post date time. And of course, the partition key is the same as before. But now let's say we want to query all the threads for a specific forum name within the last 3 months. We can do that using this query, for example. This is a function that I've written in Node.js. I receive a thread name as an input, and then I specify start and end date and forum thread name as well. So the key condition expression will be give me all the threads based on the forum name that I receive here as an input and that they have last post date time between start and end. Then I specify table name and then I specify index name. With these conditions, I will get the posts, all the posts for a specific thread name within the last 3 months. Okay, the first thing to consider is that you can have up to 5 LSI per table, even though this is a soft limit. So if you ask AWS support to go beyond the 5 limit, I think it's possible. Second thing is LSI can only be created at creation time of the table. And same happens when you delete a table, any LSI on that table will also be deleted. Another important thing is you must specify a non-key attribute for the sort key of the LSI, and this attribute, very important, has to be either a string or a number or a binary type. Also, remember that in DynamoDB, every combination of partition key and sort key for the main table has to be unique. However, for the LSIs, this doesn't hold. So the sort key does not need to be unique for a given partition key value, right? If there are multiple items in the LSI that have the same sort key value, a query operation will return all of the items that have the same partition key value as well. The last point that I want to make is that LSI are automatically synced with the base table. This is also why LSI supports both eventual and strong consistency on DynamoDB. Also remember that when you specify the sort key for the LSI, you have to specify the data type of that sort key. So every time you write an item, you have to respect that specific data type that you choose on the sort key. In the case of our last example on the last post index table, last post date time, sort key in the index was defined as a string value. So if you try to add an item to that thread table, for example, and specify a different data type for the last post date time, let's say like a number or binary, DynamoDB will refuse the write and send back a validation exception on your write operation. Okay, this is all for the local secondary indexes on DynamoDB. I hope this video was useful, and if you had more questions, feel free to post it on the comments, and thanks for watching.